Hi all, Bones here from BSA Bantams, and if you're experiencing some static on the video, don't worry about it because it's raining, so that's what it'll be, and I apologise for that. Today's job is I've got to make a press to be able to press this, not only this bearing on, there's another one the same that's flipped around the other way. And in between those two bearings will be a spacer, and that sets the end float. So I have to have an adapter that screws onto here with an external thread on it, some sleeves and a nut to pull down. So this thread is a 3/4 inch 16 TPI UNF thread. So because I don't have a 3/4 inch tap, so I'll have to screw cut the internal thread on the lathe. So first job will be to measure this up with some thread measuring wires, and then I'll make do an external thread as a guide to machine my internal thread. So over the lathe and we'll get stuck into it. Well, we're not going to the lathe straight away. I've got to measure this up. So if you've never seen these before, these are thread measuring wires. So this being a 16 TPI thread, we're going to have a look at 16 TPI, and the wire size that I need is a 40 thou wire. So we'll go and have a look, and it's these wires right here. So you actually have two wires on one side and one wire on the other, and you measure across the wires. That measures the effective diameter of your thread. So I'll write that down, and then when I cut my external thread, same measurement. I've actually had these for close to 40 years, and they are really handy at times, especially when you've got to do some odd bod sort of threads. But anyway, I'll measure this up, get a dimension, and then that'll give me the ability to screw cut the external thread. Alright, so the general concept is you've got to get it as per these instructions here. So two wires on one side, one wire on the opposite corresponding side, measure across it. I actually used to have back in the day, I used to have a piece of polystyrene foam in my toolbox for this very job, but we're just having a look across that's fine. Then I can delicately hold them, get a micrometer across it, and get a measurement. I should have adjusted the mic up a bit before there we go. Right, so this way I can get a bit of a feel on it. I've got 774. Yeah, 774. That's our measurement that we're going to be aiming for. All right, so this is going to be our test sub. So I'll cut a thread on this, get the thread measuring wires, and measure it. Set the lathe up obviously to cut the required pitch, and we'll just get stuck into it now. I don't go too fast. Now this lathe has got no like reversing gearbox on it or anything like that. So that's why I've got a bit of a run out on the end. And if you try and reverse it when the truck hasn't stopped, it actually keeps going in the same direction. So, you know, it's not a high quality machine by any stretch of the imagination, but it does a pretty good job. So what I'll do is I'll do a touch mark, 0 milli digital readout, and then we'll be able to start doing the depth of thread from there. About 42 thou, I think, or something like that. So I've just done a touch. I'll go and get the screw pitch gauge, and I'll verify that we're actually cutting the right pitch. All right, so we've got our thread getting pretty close to size, so I'm just going to throw the thread measuring wires over it and measure it up and just see how we go. My apologies for chopping my head off in it too, in the picture. And that's our thread finished. So now I'll be able to start making the actual puller. So I'm pretty happy with that. That ended up within half a thou of what the original is, measuring it over the thread wires. All right, I'll see if I can give you a bit of a heads up about what we're actually trying to achieve. So this shaft here represents this portion of your crank here. So I've got to cut a internal thread, but the big problem is, disregard this line here. The big problem is when I'm machining, my lathe doesn't have a brake, so I need some run out for the tool behind the actual thread. So when I'm machining this, I'm going to have to machine it along down there. So my tool will actually be going that way because it's boring. So that way when it runs out, it's not still cutting. I can just turn the lathe off, wind the tool back, and then bring it back out. Wind it back down, take my next pass. So that's a problem with dare I say it, a cheaper type lathe. It doesn't have all the functionality of a really good quality industrial machine. But anyway, you just got to work around it. It's no big deal. So I'll get on to machining that. After I machine this sub will have a thread machined all the way along the outside for a big nut. But we'll get this internal thread done first. So after going to all elaborate lengths to explain to him, diagram what I'm going to do with the internal thread, I went and had a look, and I've actually got a 3/4 inch UNF tap. So I've got no idea what I've got it for or where it bloody came from, but anyway, I've got one. So I don't have to go through all the rigmarole of screw cutting. I can just tap it, which is what I'm going to do now. Alright, so all I'm doing now is starting to drill out the hole to accept that 3/4 inch tap. So I'll drill this out all the way. This will also give the clearance for the little stub piece on the crank above the thread. So I'll get this done. Alright, tool change out. And we will start boring this out too. The tapping size in metric is 17.5 millimeters. I've just done 1/2 inch, so 12.7. And actually I'll change this back over to metric because I did have it on imperial when I was screw cutting that sub that I actually no longer need. But anyway, what a complete dickhead, hey? Anyway, that's what happens, eh? Not fast enough, let's get some speed into it. So just taking the final boring cut now for the tapping drill size for the tap. So time to start cutting an internal thread. So obviously lathes out of gear, the motor's actually turned off. I mean, you wouldn't want to be doing this with any chance of the machine starting. So I'm just following up, just off camera here, I'm just winding the tailstock here to follow up to keep this tap nice and dead straight. Right, let's break the chip. So me going backwards is what they call breaking the chip. So you're getting a little curl of metal in there, and by breaking the chip, it just frees it up and drops the swarf that it's cutting straight into the flute here. So this is working pretty good, pretty happy. Well, that's good. I'll polish the rest of that up now. I'll cut it off around here somewhere and put an external thread on there. I don't know what size to do yet. We'll wait and see. I'll work it out. So I've decided to cut a pretty fine thread on there. So I've actually just put a 26 TPI thread on this. And we're not far off full depth now. So that's our thread on there. What I'm going to do is drill a hole through here so you can put a little T-bar through it. It's pretty hard to see, but that's the way our internal thread and everything worked out. You can see it there. So now I will start making a nut to suit this. Sorry about that. It's trying to focus. Okay, so that's the blank for the nut. We'll get that over on the miller machine and we'll mill a hex on that. Okay, we're coming up to the fourth flat now. So I'm cutting this at 1mm increments. And all's going pretty good. So there's our nut been blanked out to size, and we're ready to start screw cutting the thread up the middle of that. My apologies for having to hold the camera. We've got the thread in there and we're getting very close. That's just, yeah, it's tightening up. So we'll take a couple of more fine cuts and we'll see how we go. So we've got our nut done. And I'm pretty happy with that. It's a good fit. I had a couple of challenges because the bore and bar isn't just got in the hole. I actually had to take a pretty deep first cut on the thread to give the bore and bar clearance around the back. So it was a little bit of a tentative job, but it's turned out pretty good. So from here, I now have to make the spaces that go over this, that this nut actually pulls the bearing down with. So we'll get into making the spaces. I'm actually going to make 2 or 3 so I can use it possibly for other stuff. But yeah. Pretty happy. Okay, so what I'm doing now, this is one of the spacers. So I'm just drilling out the bulk of the material out of the centre of the spacer, and then I'll go through with the bore and bar and I'll machine it out. So what I'm doing now is actually making the cap that will go on the very top that the nut will bear on, and that shoulder there will locate inside the spaces. So I'm just about getting ready to part it off now. Alright, so the whole purpose of making this puller is to pull this bearing on, and there's another bearing, I'll just grab it. That goes on this way, and in between these two bearings is a spacer. And that spacer shims out your end float for your crank and your crankcase. So both these bearings will have to be pressed on. Obviously I've got to take this one off because I'm changing it. So first one to go on is this spacer here. It's got a relief in there to fit over this bearing diameter here. Well, first thing to go on is actually that. So we'll just screw that down. Another spacer. Another spacer. this is shouldered. And then your nut goes on to pull it all down. So obviously it's got to pull down from a certain height. That's why I've got different length spaces in to be able to pull it down. Just chop and change them a bit. Well, these two anyway. You see this one's slightly longer. So that's how it all works. So these are all the things I've made over the last 4 days it's taken me to make all this stuff, so I'm able to reassemble my Harley engine once I get all my parts. So there's a little bit of work involved, but it's probably a lot cheaper than taking it to a bike shop. A lot of these pullers and things like that do cost a fair bit of money, so pretty happy with the end result. Yeah, there's a bit of work involved, but you know, it's what we do. So I hope you've enjoyed this video, and if you have, click subscribe. After this I'll post a couple of other channels that I actually watch, because I enjoy watching these guys and what they do. Very similar to what I do. And if you enjoy what I do, go and check out these channels as well. So Aid at AG Engineering. Aid does a lot of work on motorbikes, a very skillful man with a great workshop, and does a lot of repair work and things like that. Dean at Retro Mechanica. Dean also does a lot of engineering type stuff and is currently building a Bantam engine, and he also got hold of one of my electronic ignitions. I don't know how he managed that, but so he's fitted that up, and that engine's not too far off, probably going back in the bike and going for a test run. And also Carl Wilson, so check out his channel. Also does a lot of engineering type stuff, refurbishing old machinery and just the general engineering stuff that I love watching as well. So I'll post those on after this video so you can see those sites as well. Hope you've enjoyed it. I'll see you later.